Okay. What's up, guys? We're back. What's up, guys? We're back out with 5.4 part 2.
Yeah, I'm eating again, obviously.
You might be taking up the whole screen. Let's go. Ka-chow.
You guys are weird. Hey. So, 5.4 today, we're finishing it. And then tomorrow we have a little project that we're working on in class. If for some reason you are absent tomorrow, don't worry. I put the project online on Canvas, so you can work on it over the weekend, and it'll be due on Monday for you. But everybody who's here tomorrow in class will be able to get it done in a class period, and then hopefully we'll all get 100, and that'll bring up everybody's grade. Because we have a test on Friday, that might kind of bring down people's grade. So we got to get that project grade in there to help it. Okay? Don't worry. The test, I went through every single question on the test, and I made sure the test questions are fair. If it wasn't fair, I got it out of there, okay, and replaced it with a much more fair question. I even added a bunch of extra questions, which I know sounds like a bad thing, but when they're questions like, write radical 7 as a number with a rational exponent, and it's 7 to the 1/2 power, and you can answer it in 3 seconds, and I put 6 of those questions on there, just like the quiz that we just took, and pretty much everybody got the first 6 questions correct. Right? So there you go. When you put more questions like that on there, it makes those hard questions worth less when you lose those points. Okay, does that make sense? So it's a good thing. So that test is on Friday. We have a review day on Thursday. Your practice test is due on Thursday. All work shown. I will have my notes and work up on Canvas. So if you're using that, great, but you better have your work shown, okay? Because if you have an answer there and you can't explain to me how you got it, and you're like, oh, just use your notes, but all you did was give me the answer, you better be writing everything that I wrote if you don't know how to explain it yourself.
Rational is like a fraction.
Yes.
Okay.
So a rational exponent is just,
Yeah.
Okay. Yeah, so that number 1,
This.
yeah, that number 1, I put 6 more of those questions on the end.
Yeah.
Just to be just get all those right, and it makes the other ones not worth as much. Okay?
Yeah.
All right, so let's review really quickly where what we were working on yesterday, and then we'll continue from there. So we were talking about exponential growth, and we were looking at these 2 functions. Are these functions the same, or are they different?
They're the same. B equals 1 plus R. Same.
I love when I can just pause and then you guys start just arguing with each other. I love it. They're the same, but they're different. Both of you, all of you are right. They are the same because, as Bo said, B is the same thing as 1 plus R. They represent the same thing, but they do look different, right? Because this one's broken up into 2 different parts, so they are different, but overall, they function the same way. Get it? They function the same way. They work the same way. They function the same way.
What was
You didn't like that joke? It was a pun.
No, not you.
Oh, yeah, I get
You
that.
spilled water on this man?
It's like a.
This
Oh,
man.
gotta get the just crispy.
No, shush. Okay. So, this is our exponential growth function, but it can also be modeled with a growth factor. We talked about that yesterday, right?
Yeah.
How R represents the
Rate.
The rate, very good. 1 represents
100%, like
the
the whole.
100%, the whole thing. And that is what allows us to come out with our final answer instead of having to add our answer to the original value. The original value is included in the percentage. So it's what the function will spit out the final answer instead of just,
This whole lesson, I'm going to be working with percents.
yes. What's wrong with percents? They're just,
It's like
What? Tell me.
They're easy.
Give me one thing that's like. Tell me what confuses you about percents. Like-
They know that out of 100, but then if you go into like, out of 100 into the different numbers, and that's.
Well,
can't
every
count.
guys percent. So like 10%, guys. Shh. That literally means 10 out of 100.
Yes, I know. I'm talking about like if it's not just out of 100.
So 10 out of 100 would reduce down to 1/10, which could be written as 0.1. Right? That's percents. They're just numbers with a percent sign. What? Ugly numbers?
I'm just bad at percents.
But if you think about what a percent actually means, they're just like reading it out actually tells you what the number is. So like 75% would be 75 out of 100.
It's still. I'm talking.
Points.
I get that, but I'm talking about like if it's 10 out of 2,000.
So that's not a percent. Percents are always out of 100. So to answer your question from before, we're only working with percents out of 100. We're not converting fractions into percents. I think that's what you're worried about. We're not converting fractions into percent. We're not saying like, what percent is 8 out of 16.8? You know, we're not doing anything crazy like that. We're just using a percent as a rate, converting it to a decimal, which is super simple. You just put it out of 100 or move the decimal over twice, and that's it. Okay. So over here, we worked with the problem about Hillville that started out with 5,000 people. It had an annual growth rate of 15%, which we simply plugged in for our R, our growth rate. And then it asked what the population would be in 5 years. So that is what we put in input. That is what we put in input, the machine. That's what we put in the machine, and to see what came out. So when we put in the 5 years to our input, our X value, and we typed this into our little EOC calculator just as it is, what came out was our final answer, our final population amount.
Okay, I'll stop.
Go, shush.
Yeah, go.
So, did you guys find that to be pretty simple? The fact that all we had to do is plug in numbers and then the calculator does it all for us, and we don't even have to worry about order of operations, because when you plug it in exactly as it is to your EOC calculator, it does order of operations for you. Okay. Then we talked about Valley Town, which also had a population of 5,000, but this time it increased, so growth, right? It increased by 1,000 annually. Each year, it increased by 1,000. And what did we say? Was that exponential? It was linear. And why would we say that that's linear?
Because it's adding.
It increased the same every year.
It's not
Because it's increasing the same amount every single year. It's not increasing the same rate every year, it's increasing the same amount every year, which is additive. It's not multiplying. Multiplying would be exponential. Okay, then we started talking about compound interest. Did you guys get this formula down yet?
Yeah.
Yesterday? We did?
Yeah.
Okay, you have it in your notes? Good. And we taught, I don't know if we did this table, I think I might have done a much simpler one with like $100 and like 5%
Yeah.
growth. Yeah, so we talked about the difference between simple interest, which is very simple, and the difference between compound interest, which keeps growing based on each last amount, which is what makes it exponential.
Wasn't it like where like you would like find like a 5%, then after you would add that on, and then like the next year?
If you were to do it the long way without a formula, that's exactly what you would do. You would continue to find 5% of that amount, and then the next year you'd find 5% of the new amount, and then the next year you'd find 5% of the new amount, and you would have to do that until you reach the number of years that it's asking for. So if it's asking for 20 years later, you're gonna do that 20 times. But the beautiful thing is, we have a formula.
Oh.
The most beautiful part about the formula is you don't have to memorize it. It's on your EOC reference sheet. We talked about that, right? Did I show you where it was on your EOC reference sheet?
Yeah.
No. Yeah, you did.
You did.
Sorry, my brain is slow. Yeah, no.
Ooh.
Right here, did I show that to you?
Yeah.
See.
And you copied it down?
Yeah.
And not only is it on your EOC reference sheet, but they even explain what each letter means. That's awesome. There's not a whole lot on your EOC reference sheet, so this is a beautiful thing. Okay? It's gonna be so simple to solve these problems because they're gonna give you all the information you need. You plug them in to the formula that you are given, and then you write it into the calculator, and the calculator does all the work. This is one of the easiest lessons we could have. Because even though the concept is kind of a little tricky, where you have to really understand, well, what's actually happening, the actual processing of the numbers is the easy part, right? Yes or no?
Nothing more
Oh,
Quit your yapping over there. Howdy.
all right. So real quick, let's just review what these numbers mean. Should I do the colorful one or the big one?
They're colorful.
Colorful.
Okay. So A represents the final amount, or the answer, or the output, if you will. P, what does it say?
Principal amount.
Principal
The
amount.
main.
Isn't that the same thing as the other thing with the function before? Yeah?
I said my
Our exponential growth function.
symbiote. Oh, the asymptote.
No. What is P the same as?
B.
A.
Oh.
A is the initial amount. P is the principal amount. They mean the exact same thing. And I'm just drawing the connection between those just so you can like not be intimidated by all of these formulas because they actually mean the exact same thing. This one is going to be more useful for compound interest because compound interest involves just a little bit more detail, and this has a place for all of those details. But again, we just punch into a calculator. Yeah? If you want to miss this, that's totally fine. That's up to you. Now you don't know what to do, right? Totally up to you. I'm teaching. You will miss the part that you are in the bathroom for, okay? So P is the same thing as the initial amount. R1 is the same thing as the one over there. It represents the 100% or the whole thing. Now R here and R there are the exact same thing, the rate. Why is it over n? Did we talk about that yesterday?
No.
No? Why do you think it's over n? What does n represent?
The number of times per year the interest is compounded.
Okay. So explain that.
Oh, I know. The rate of it, like the rate is over the number of times per year because it's like the number of times per year is like how many happens. So it's like the same.
How many times it happens?
Yeah.
Yep.
So it's like the same. So basically.
Right.
Yeah.
Yeah. So the rate has to be broken up over those 4 times,
Yeah.
right? And it's brought to the power of the n times t. Why?
Oh, I was gonna say it's like the rise over run of the interest.
I agree to disagree.
What?
It is kind of like that. It is kind of like that. You're right, you old genius. The rise, if I say it, you're gonna freak out. The rise over run of That's exactly what, okay. He was making a connection between a slope, and it is kind of like that, but it's okay if you don't make that connection.
N is like the amount of times through a time.
Mm-hmm. Yeah,
The amount of times through t.
good.
Like out of t.
Yeah, so if t represents the amount of time in years and something is passing, let's say we want to know in 10 years, right? What happens in 10 years? But let's say something's compounded quarterly. what would that mean for
It
n?
happened like 4 times.
It would happen 4 times. So what this is really being raised to isn't 10 years. It's 10 years 4 times a year, which is how many times? 40. So this is being brought to the 40th power instead of just the 10th power. And if you don't understand that, that's okay. We're just talking it through and then we're gonna put it into practice. Raise your hand if you kind of understand what I'm saying with this compounding something other than 1. Very good. Okay. Now, in this example where it says the table shows it $500 compounded annually, you don't see it over anything and being brought to a power being multiplied times the year because it's compounded annually. Annually is just once a year. And something being over 1 doesn't change. The years being multiplied times 1 doesn't change. That's why you don't see any of that in this example. Compounded annually doesn't affect it. But compounded quarterly, compounded monthly, what would that number be? 12. Compounded semi-annually, what would that be?
Almost, like every other.
No, semi-annually, meaning twice a year, or every 6 months.
16.
It would be 2, because it would be the number of times it would be happening. The number of times it would be happening in a year, which would be 2. Okay. Now, what about, this is crazy. I'm trying to wake up Jacob by making noise with the Jolly Ranchers.
Jacob, wake up!
Okay, he was sleeping with his eyes open.
That looks tasty. You should give me
What
one.
about biannually?
1.
Lex? No, you can't think about it after you raise your hand.
2.
No.
Biannual.
Jacob, you awake?
5 means 2.
What?
I was gonna say 2.
No. Faith? No.
1.
No. Yeah? No.
Negative 2.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Every 2 years.
Yeah, it is every 2 years. What number would that be if we're ever to plug that in?
Dose.
Grayson?
0.
No.
I said 1.
0.5.
Yes.
What?
0.5 or a half. Yep.
I was kind of close.
You didn't say that.
2,
I thought every 2 years, bro.
I know, but every 2 years isn't a number that I would plug in. That's just what biannually means. It means every 2 years. But what I was asking for, what would be the number of times it's compounded annually, would be 0.5 times or half times. All right. See, it does make sense.
Yo, you should slide the Jolly Ranchers.
All right.
That was evil. That was
Now, this graph is just showing you what it looks like when you compare simple interest happening and compound interest happening. So they give you the same starting rate, or not starting rate, starting value. The graph below shows $10 at 5% simple interest and 5% compound interest, compounding quarterly. So they both start at 10. The simple interest increases at a steady rate, causing a steady regular slope, causing a simple line because it is linear. The compound interest, compounding quarterly, starts curving upward, higher and higher, and as the time increases, it's going to get higher and higher and higher, faster and faster, bending more and more and more, reaching for the sky. That's what happens with compound interest. It's exponential growth. That's what compound interest is. Exponential growth. That's pretty much all I want to say about this, and then we're going to go to the next example. Do you guys understand?
Keep adding into
No. It's a good question. It'll just shoot up higher and higher and higher, faster and faster and faster, but it will never bend backwards. That's a good question.
She does it.
Which part? We did the homework together today, and you got that. Which part did you not
I'm a
understand?
good liar.
Oh, okay. Which part of this do you not understand? Okay, so all it's doing is it's showing the same starting value, starting at $10. It's showing what it looks like if something is accruing interest. Accruing just means getting interest. Or adding interest. If the interest is added simply, that means that you're adding the same amount each year. That's just a regular slope of a line. It's going up the same amount each year. The same amount each year as x increases by 1, y increases by the same amount each year, causing a straight line. The compound interest increases by each new y value. So 5% of the first value, or $10, it will increase that much. And then the next 3 months, because it's quarterly, so every 3 months, it's going to increase 5% of the new dollar amount. And then in 3 months, because it's quarterly, it's going to increase 5% of that new amount, which is higher than the last one. And then it's going to increase 5% of that new amount, which is higher than the last one. So if it continues to increase higher and higher, faster and faster, it's going to bend upward, increasing faster than a steady, regular increase of the same number every time. Every time this increases, it's exponential. Multiplicative. We good? I'm gonna move on. She's frozen in time. In space. Anytime you leave, you are missing instruction. Personally, I would wait until class is over, but that's just me.
Someone could cost me $3 million.
Yes, you could, but will you? If you're in class, then I can guarantee.
I'll watch the videos, I promise. I'll go fast.
I've got an idea.
I'm listening.
Oh, does it include Jolly Ranchers?
I should say like a magic word, and then tomorrow when Grayson comes in, I'll be like, did you watch the video while you were in the bathroom? And I'll say, what was the magic word? What's the magic word?
Pie.
Pie, okay.
Banana split sniffer.
Okay. What? Grayson, if you're watching this, you will come into class tomorrow and say,
Banana split sniffer.
banana split sniffer. You're gonna wanna write that down in your notes, because you're taking notes right now, right? Because you missed this part, you're in the bathroom.
Yeah.
Write down banana split sniffer, and I'll give you a little treat tomorrow, okay? If you actually watch it.
Write it. I got a Jolly Rancher.
Okay. Shh. Anyway, don't tell him. If you guys tell him,
And whoever tells him, I'm going to find you.
We're gonna get over myself.
okay, now listen. Just this will be the test to see if you watch the video. Anyway, Kimberly's family invested in a certificate of deposit for her when she was born. Oh, isn't that sweet? So a certificate of deposit is basically like, oh, the baby's born, I'm gonna give the baby some money. But they don't actually like hand the baby a bunch of cash, because that would be really weird.
They gave the book. They gave the baby $3,000 bucks.
It's kind of like, I'm gonna put this aside, and then you can have it when you're older. But these special accounts accrue interest. So the money that you put in
Crazy.
makes money just by sitting there.
I'm doing your dance.
It makes money just by sitting there over time. So you give a little gift, and that gift starts multiplying. It starts growing exponentially. And then when the baby grows up and goes to get its money, it's more, when the baby grows up and wants to get the money, it's more than what it started. Okay? Shh. Make sure you watch the video, okay?
How old are they?
All right. So, what is the value of the CD at the end of 5 years? Okay, the kid already wants its money at 5 years old, which is funny. Usually it's like 18 years old they can get the money, but at 5 years
I thought
old,
it was like 16.
it just doesn't. It's different for every month. Apparently this 5-year-old is like, I'd like to see how much money I have in my account now. So mom's like, okay,
It's like his
let's
first
take a
birthday.
look. So mom says, well, we put $3,000 in the account, which is lot of money. I wish my family did that for me. $3,000 in your account when you were born. We were so happy. And the annual interest rate is 8%, and it compounds quarterly. Okay? Ooh, compounding quarterly. That means every 3 months, it's going to grow by 8% of each last. Why are we talking? I'm telling a story up here. We don't need our calculators right now.
I'm doing them El Mato.
We aren't doing El Mato right now. Quiet. Now, we need our compound interest formula, but I don't have it memorized. Good. Your EOC reference sheet has it, so no stress. Just use your compound interest formula. All we need to do is fill in the little numbers. The amount deposited is $3,000. What is that?
$3,000.
No, what is that?
That's P.
It's P, our principal amount, which is the same as the starting value or the initial amount. So that goes in for P, our $3,000. Our 1 is always going to be 1 because that represents the whole value of the principal. Now we have our rate over our number of times compounded per year. Our rate, it gives us 8%, which simply means 8 out of 100, which means 8 hundredths. So if you just read it as 8 hundredths, you can write your decimal 0.08. Divided by the number of times it's compounded annually. If it says it's quarterly,
So he's fine. Did they add that again when it's
4 times a year.
what do you mean?
You said he wanted it for his 5th grade.
Yeah, he just wants to know how much money is in his account right now, so he's checking to see how much is there. I don't know if he's actually gonna take it out and spend it, but he wants to see how much is in my account right now after these 5 years, okay? But it's not just compounding annually every 5 years, it's compounding every 3 months, right? Because that's quarterly. Anyway, what? Because that's the number of times. I'm saying it like a story. It's compounding every 3 months because that's what quarterly is. A year is 12 months. If you break up 12 into 4 equal parts, that's 3 months each.
Okay, that makes sense.
Yeah.
How'd you miss that?
Everybody, can you sit?
Yeah, they're trying to the show.
Did you see what I saw? Like, that was weird, right? Like, okay. Anyway. So, I know I was saying like every 3 months, we're just talking about what's actually happening. But it's compounding 4 times. 4 times in a year. So it gets divided by 4. Shh. And then it's being raised to the power of NT. We sub in the same number 4 for N. The same number for N down here, 4. And then we have the time that passes. And this kid turns 5 years old. He says, "Where's my money?"
Now he's the man.
I mean, this kid, you never know.
Where's my money?
I mean, he's got $3,000 in the bank. He wants to know what's going on with it. So T, guys, T representing the time in years would simply be 5. You want to know the beautiful thing? You could literally type in this exact thing into your EOC calculator and it will do the math for you. You could actually type in this exact thing and just put the 5 here.
What the fuck?
And put that, you want me to show you? Okay, so it's 3,000. If anybody has their Chromebook available, you don't have to do it, but 3,000 times 1 plus 0.08 over 4 to the 4 times 5 power. Can't put commas. 5 is how many years are passing? Because it has to be the number of times compounded annually times the number of years. So I'm going to go to my EOC calculator.
Laura, you can get there.
Yeah, I got it.
And I'm going to type it in. 3,000, open parentheses, 1 plus 0.08, and then I'm going to put it over, so divided by 4. Then I'm going to close those parentheses, then I'm gonna raise it to the power of 4 times 5. Done. I didn't even have to press enter. No, stop. Stop. I didn't have to press enter. I didn't have to solve anything. I just used the information that it gave me, plugged it in, and I got my answer rounded to the nearest cent would be 84 cents, so $4,457. So that $3,000 compounding quarterly is getting close to almost $5,000, right, or $4,500. It increased almost $1,500 by the time the kid turned 5.
Oh my
Why didn't my parents do that for me? No fair. Yeah, right?
Yo, the baby's dad's going on for real. The baby's dad's going on.
Now here's a question. I'm gonna ask this question before I skip to the next page. I've got a question. Is anybody paying attention?
I think Jason needs some help.
Oh, it's a great one. Does anybody want to answer?
Go to sleep. I see a mushy dog.
So we just talked about what the amount of money would be like after 5 years if the interest is compounded quarterly. Do not say anything out loud. Think about it first, and I will call on you. And do not raise your hand until you have an answer that you've thought about.
I'm listening.
If the interest was not compounded quarterly, but instead compounded annually, would she end up with more money or less money than compounded quarterly? Faith, tell me why.
Because,
You're right. Tell me why.
annually is once a year, and then, what was the other word?
Quarterly.
Quarterly is something more than once.
Yeah, so it's, yeah, so we're, with quarterly, we're adding on to the newest value more time. So it's getting bigger and then, but annually, it's only adding on once a year. So very, very good.
How's that getting small? Oh, are you upset? Just
It's not getting smaller. You make more money when it's compounded quarterly or more times a year because you're like capitalizing on that newest bigger value. Now, I got another Jolly Rancher question for you. I didn't ask it yet.
I know the answer.
You didn't know, you know
What's the answer?
What's the answer like?
What's the answer? If you get it wrong now, then you can't have a chance of getting it right when I ask
hold
it.
up. Say it quick.
Okay. You have to go to the bathroom? Okay, you gonna watch the video tonight? You're gonna fast forward to this part? Okay. Shh. What am I hearing?
It's someone really
It's
loud
like aliens
bass.
coming to abduct us.
They're gonna knock the bow.
With the baseball.
They're taking him back.
With the
No,
baseball.
they found me.
They can't take
They're
Joe.
coming back for their
They can't
brother.
take Joe.
Wait, we need to think of a word. Wait, what word?
No, I'm not.
No, don't do that to her.
Whoa, you just gave it away.
Bow.
What away?
Stop.
Bo is special.
Yep. Yeah.
That's why the aliens are coming
He's a
in.
special cookie.
Guys, I have 10 minutes and we're actually doing really well on time, surprisingly. All these candidates. I'm gonna get there, oh my gosh. Anyway, I'll get there in a minute. Just gotta be patient as I get to the question. That might get you a jolly So,
Good job.
on this page, they actually, now Faith, when I asked that question, Faith figured it out just logically, what would make sense. Well, if it's compounded annually instead of quarterly, it's not gonna compound as often, so she won't make as much money. Shh. And that was logical, very good logical thinking. Now, this example actually works it out to compare the growth rate, or I should say the, what's the growth factor, or the constant ratio, just by comparing the rate of 8% and the number of times it's compounded. Now, they're not even using the initial amount. They're not even using the time that's passing, like in 5 years or in 10 years. They're just comparing the formulas using the interest rate that's exactly the same and the number of times it's compounded, which for annually it would be 1 and for quarterly it would be 4. Now, how can they figure that out? Well, this one's really simple because this is over 1, so that would just be 0.08, and it's to the 1t power, which would just be t. So then you would just add 1 plus 0.08, and you would get 1.08. That's your constant ratio, that's your growth factor. Over here, we have 0.08 being divided by 4 because it's quarterly, which sounds like the rate is going to get smaller, right? Because if it's being divided, doesn't that mean it's not going to be as much? But then it's being raised to the power of 4t. So when we divide 0.08 by 4, we get 0.02. Calculator can tell you that. That's 1 plus 0.02, so 1.02 being raised to the, being raised to the power of 4t. Now, for my Jolly Rancher question.
Okay.
What exponent property, wait, I almost gave away the answer. What exponent property, hold on, how do I want to word this without giving away the answer? Okay, notice that the 4 and the t are being what? Multiplied together. What exponent property allows 2 exponents to be multiplied together, Lex?
I know this answer. I know
You
it.
should have thought of it before raising your hand. What?
When you exponent, when the exponent gets exponented.
Very good. Let me give you a diameter. That's the legs definition. What's the textbook definition?
It's exponent to an exponent. Oh,
No.
power to the exponent. Power to the exponent to the exponent.
You're trying so hard. I'm not giving this to you. I didn't call on you.
Power to a power.
There you go.
Yes.
You're welcome.
Yeah, you are welcome.
I didn't mean
Can I
to.
trade this out for a blue raspberry?
No, enjoy it or give it away.
Take it.
Because of our power to a power rule, we can actually go backwards power to a power. If these exponents are being multiplied together, we can rewrite this as 1.02 to the 4th power to the t power. And because we can break those up, we can simplify 1.02 to the 4th power.
Which should do first? The inner one.
Please. 1.02 to the 4th power is 1.0824316. Actually, it's technically 1.082432216. One of my first period kids actually did it on a calculator and realized that the book did not include one of the numbers, so I'll be emailing them about that. So funny, it's like, so what a random thing to leave out. But anyway, this is pretty close. So you can see that this growth factor is 1.08. This is 1.08243116, which is slightly higher. So the quarterly has a faster growth rate or a faster growth factor. What? What happens to P? So nothing. We're not actually solving for a certain amount of time or a certain amount of principal. We're just comparing the growth factors with annual and quarterly. And all we're doing is proving that a quarterly compound will increase faster than an annual compound. That's all we're doing. Okay, I have one more thing, and it's super easy, because guess what? Exponential decay is the exact same thing as exponential growth, except you subtract
It's that
instead
backwards.
of add. Okay. Don't worry about the word problem yet. Hold on. Stay awake. Look alive. Don't worry about the word problem part. Notice how this formula is exactly the same as the exponential growth formula, but instead of plus r, it's minus r. Instead of adding the rate, stop. Instead of adding the rate, we are subtracting.
Oh, it's
the
subtracted
rate,
it.
because it's decaying. It's going down instead of going up. Really logical, right?
It's decaying. It's decaying.
It's still multiplicative. It's not subtractive.
Oh wait,
It's
yeah.
still multiplicative.
Wait,
Okay.
wouldn't it be
No. No.
dihibitive?
Sorry?
I see what you're saying. It's still multiplicative, but it's multiplying by a number less than 1,
It's a
which does make it. So if you want to think of it as divided, kind of, but we're multiplying by a number that's less than 1, because when you subtract a decimal number like 0.25, for example, will be this one. When you subtract it, you're going to get 1 minus 0.25. You'll be left with what?
Negative.
No.
Oh, wait. Oh, 0.75.
0.75, which is a number that's less than 1, so that's what's going to cause the decrease. If you exponent a number that's less than 1, it's going to cause a smaller number, right? That's what's going to cause the decrease. Now, a video is labeled a fan favorite, so they're basically talking about, Mrs. Legg was here, math YouTube channel. A video is labeled a fan favorite, because all my videos are super popular. And yeah, and Amelia, Mrs. Legg, posts a video. Mrs. Legg posts a video about exponential decay, and it gets 8,192 views on the first day. You know who one of those views is?
Me.
Grayson, because he said he would watch it. You have to watch that part where you went to the bathroom, okay? Yeah. I'm gonna test you on what I talked about. What I talked about during those 2 minutes, okay?
What the flip? What the flip?
So Mrs. Legg gets over 8,000 views on her first day. So it's basically a fan favorite, because a fan favorite is at least 1,000 views per day. So obviously I'm a fan favorite. The number, it's imaginary world.
I know.
Because people love math.
I'm just
in my
saying,
imaginary
as
world.
students.
That's not like the worst.
The number of views decreases. What? I want to be in a word problem that increases. The number of views decrease by 25% each day after that, because y'all need to watch my videos more. Stop giving me exponential decay.
Yeah, Grayson.
It's embarrassing.
Yeah, Bobo.
In how many days total will the video stop being a fan favorite? How many views? Under how many views does it have to be to stop?
300.
0.
2,007 million.
Read the problem. 1,000. It has to go under 1,000 views to stop being a fan favorite. So it starts at 8,192 views. The next day decreases by 25%. The next day decreases by 25% of that new value. The next day it decreases by, I know it's so sad, by 25% of that lower value. The next day it decreases by 25% of that lower value. So it's decreasing exponentially, which means it's basically plummeting. Okay, it's very sad. Now, how would we solve this? We would simply, now they give the first couple of days. So at 0 days, or on her first day, before the first day is over, so 0 days, it's over 8,000 views. After the first day, that 25% decrease causes views of about 6,000. Then, after 2 days, 25% decrease from that causes about 4,600. Then, after 3 days, 25% of the second day's views causes under 3,500. So it's going down, down, down. Eventually, it's going to go under 1,000. They want to know after how many days will that happen. I'm going to let you guys go in a second, but look, all you have to do, excuse me, I said I'm going to let you go in a second. All you have to do is plug in your starting value, your initial amount, and your decrease, and your decrease or your decay rate. And then, now here, they had to do, they did 4 and then 5 and then 6 and then 7 days, and then found which day did an output of less than 1,000. They found it to be 8 days went under 1,000. But if the question was like, how many views would it have after 6 days? You would just plug in a 6 for your exponent and then solve it on the calculator. That's it, you guys can go.